In this video I'm going to show you Edexcel A-Level Maths Paper 1 from June 2022, question 8. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England, and please like and subscribe this video. Now question 8 is quite a long question, so what I'm going to do is show you the whole question first, or at least the beginning of it, and then I will do the question itself on a separate page, but with enough shown that you could remind yourself of what's needed in the question, needed to solve the question. Okay, so question 8, the first thing here is we notice we're given this diagram, figure 2, and on the y-axis is v, and on the x-axis is t, and we'll see that there's this kind of hump shape here. It says a car stops at two sets of traffic lights. Figure 2 shows a graph of the speed of the car, v meters per second, as it travels between the two sets of traffic lights. So it stops at one traffic light, the speed increases to a maximum, then it slows down and stops at the second traffic lights at time t. The car takes 2 seconds to travel between the two sets of traffic lights. The speed of the car is modelled by this equation. V equals 10 minus 0.4 t times natural log of t plus 1, and small t is between 0 and big T, which is the end of the journey at the second traffic light, where t is the time in seconds after the car leaves the first set of traffic lights. And then we have to find a number of things about this equation. Eventually we're going to find that this time t and an approximation for the maximum speed, the time of the maximum speed of the journey. So what I've done is, because there's so much on this question, I've duplicated the question but without the diagram. So we can now see here the speed of the car is modelled by this equation, and the first part A, is find the value of t, which is, remember, when the velocity is 0. So for part A, when the velocity is 0, we'll have 0 for v is equal to 10 minus 0.4 t, and then it will be natural log of capital T plus 1, and there's two solutions for that, because either t is equal to 0, which is the beginning of the journey, or t equals 0 is the beginning, or 10 minus 0.4 t is 0, in which case t is 10 over 0.4, which is 25 seconds, which is the answer for the question here. So this is the answer here. Okay, part B, show that the maximum speed of the car occurs when t equals 26 divided by 1 plus natural log of t plus 1 minus 1. Okay, so if we have a maximum of a curve, we want to find where the gradient is 0, or in this case dv dt is equal to 0. Now if we look at the formula, we have two functions, expressions involving t multiplied together, so we're going to use the product rule. So using the product rule, we can find, I'll put it here, I need to write it quite small because I need to put quite a long, at max speed dv dt is equal to 0, which is, now I'm going to use the product rule. So what we do is we differentiate one expression, leave the other expression alone, and then vice versa. So if I differentiate this one, it would become minus 0.4, and then it will still be times natural log of t plus 1. And then if I leave the first expression alone, I'll have plus 10 minus 0.4 t, and then differentiate natural log of t plus 1 will be 1 over t plus 1, which I can write on the bottom here. Now, what I can now do is bring this to the left-hand side and then divide through by 0.4. So this will give me natural log of t plus 1, and then if I divide through by 0.4, I can divide the top by 0.4. So that will be 25, 10 divided by 0.4, minus 1t, so minus t, and it will still be over t plus 1. And now what I can do is, I can see in the answer I need to have this 26 in there, so I need to be a little bit clever about how to introduce that. I can say this is the same as 26 minus t minus 1 all over t plus 1, which I can now write as 26 over t plus 1 minus, and if I put this t, because it's minus a t plus 1 in brackets over t plus 1, which will give me a 1 here. So that will be, should have given myself a bit more room here, 26 over t plus 1 minus 1. Okay, now what I can do is I can now rearrange this a little bit. Should make that equals a bit more clearer. Okay, so now what I can do is say natural log of t, and I'll bring this minus 1 to the left-hand side is equal to 1 plus 26 over t plus 1. Which now means if I multiply, if I multiply by t plus 1 and then divide by this, I will get t plus 1 is equal to 26 over 1 plus natural log of t plus 1, and then that will give me my final answer, which is t is equal to 26 over 1 plus natural log of t plus 1 minus 1, which matches the formula that I'm required to prove. Now what we see is we can use this formula as an iteration formula. So it says tn plus 1 is equal to 26 over 1 plus t natural log of tn plus 1 minus 1. So here what we do is we enter the initial value, t1 is 7, and press equals on our calculator, and then we can enter this right-hand side expression. Wherever it says tn, we put an ans. So it'll be 26 divided by 1 plus natural log of ans plus 1, and then minus 1. And then if we press equals, it will give us a second value, and then when we press equals again, the third value will be based on the previous answer, and so on. So if we do that, we get we can use the iteration formula. So it says using this iteration formula with t1 equal to 7, find the value of t3 to 2 decimal places. So doing that, we have t1 is equal to 7. So we enter that formula in the calculator with ans instead of tn, and we get for the t2 is 7.443 to 3 decimal places, and t3 is 7.298 to 3 decimal places. Now for part C2 of the question, it says find by repeated iteration the time taken for the car to reach maximum speed. So again, if we were to keep using this formula again and again, hopefully it will gradually converge on a number, and it does indeed do so. You can keep pressing equals and equals and equals, and eventually the number will appear to be constant because it reaches the limit of accuracy on your calculator. So in my cases, what it gets to, as I find that t eventually goes to 7.332 800,321 on my calculator. That's the limit of the accuracy it's got here. So time for max speed, if we round that to 3 decimal places, is 7.333 to 3 dp. And that completes question 8.